My name is Jung-Lynn Jonathan Yang. This is a work in progress video to demonstrate that I'm the sole copyright holder and sole creator of this graphic that summarizes the concept of a singular point in calculus. This graphic is made for my own personal use. A singular point is a non-differential point essentially on a graph. The first derivative, the derivative doesn't exist for a couple reasons that are presented here. In the first two cases, in the first two rows, the derivative does not exist because there is a sharp, abrupt change in the slope at that particular point that I've noted. We can have a corner, which is the graph on the left and on the top and middle row, or a cusp on the right column. How I think about a corner is just that the portion of graph that's approaching that corner point is linear, whereas with a cusp, it is curved. Depending on the orientation of this point, we can have a maximum or a minimum. If we have something that looks like a mountain peak, whether it's a corner or a cusp, we have a maximum. In the other case, we can have a valley. If we have the corner or the cusp with a pointed end downward, then this point at the bottom of this valley is the minimum. Another case where the derivative does not exist, in other words, a singular point, will be a point on a graph with a vertical tangent line. The derivative is a description of the slope of the graph at a particular point. And in this case, that particular point has a tangent slope that is vertical. And vertical slopes are infinite. Because infinity is not an actual number, then the first derivative doesn't exist. In these two cases on the bottom row, it's not a min or a max. We don't have something that looks like a mountain peak or a valley. It's actually called a inflection point, but that's more relevant for the second derivative test. The purpose of this graphic is just to recognize what are singular points, either something that's sharp, where that derivative just doesn't exist because the left slope and the right slope are different, or that slope at the point is infinity.